It is the winter of 1942, and somewhere in the frozen interior of Alberta, Canada, a man stands knee-deep in snow watching a lorry drive straight into a lake. Not a frozen lake, not a solid, reassuring sheet of ice capable of bearing weight. Something stranger altogether. The lorry crosses, the ice holds, and the man watching, a quiet, brilliantly eccentric scientist named Geoffrey Pyke, allows himself the faintest trace of a smile. What he is looking at is not ice, not exactly. It is a substance that his team has spent months perfecting in secret, a material so improbable, so stubbornly resistant to the physics of war, that senior military figures will eventually read the classified reports and assume someone has been at the gin. It is stronger than concrete, it melts far more slowly than ordinary ice, it can be repaired with seawater and a pump, and according to the plans already being drafted in Whitehall, it will form the hull of the largest warship ever conceived, a vessel so colossal it would make every aircraft carrier then afloat look like a bathtub toy. The project is called Habbakuk. The spelling, misspelled from the biblical prophet's name, would remain uncorrected throughout its classified life, an appropriate kind of error for a program this surreal. And yet, for a period stretching from late 1942 into 1944, it was no fantasy. It had Churchill's personal endorsement. It had Lord Mountbatten's enthusiastic support. It had scientists, engineers, and naval architects working in earnest. It had a prototype floating in a Canadian lake that refused, with quiet stubbornness, to melt. This is the story of how the British very nearly built an aircraft carrier made of ice. To understand why anyone thought this was a reasonable idea, you have to understand what 1942 felt like from inside a British Admiralty conference room. The Battle of the Atlantic was not being won. German U-boats were tearing apart Allied supply convoys at a rate that threatened to strangle Britain's capacity to wage war entirely. In November 1942 alone, the Allies lost over 700,000 tons of shipping. The cumulative toll since 1939 was staggering. Millions of tons of food, fuel, and materiel dragged to the bottom of the North Atlantic. The fundamental problem was air cover. Allied aircraft could protect convoys near Britain and near North America, but in between lay what sailors called the Black Pit, a stretch of the mid-Atlantic so far from land that no patrol aircraft could reach it. U-boats operated there with horrifying freedom, surfacing in daylight to recharge batteries, and hunted night with near impunity. The solution was obvious: extend air cover over the Black Pit. The method of achieving it was anything but. Aircraft carriers were the answer in theory. In practice, they were desperately scarce, catastrophically expensive, and took years to build. The steel required for a single fleet carrier was enough to construct dozens of destroyers, hundreds of tanks, thousands of lorries. Britain could not build carriers fast enough. The Americans were building them rapidly, but not rapidly enough. Something else was needed, something radical, something cheap, something that could be produced without diverting the steel, the shipyard berths, or the skilled labor that the war was consuming at every turn. Geoffrey Pyke, a journalist and independent thinker attached to combined operations, had been generating unconventional ideas at an almost alarming rate. Most were ignored, but in late 1942, he submitted a memorandum so audacious that it could not simply be filed and forgotten. He proposed constructing a mid-ocean airbase from ice. The North Atlantic, he noted, produced the raw material in vast, essentially free quantities. Ice floats. Ice can be shaped. Ice, in sufficient thickness, could absorb torpedo strikes and bomb damage and simply be patched with a hosepipe in sub-zero temperatures. The whole concept was, in Pyke's estimation, a matter of applied common sense. If you are finding this interesting, a quick subscribe helps more than you know. The material that made Habbakuk credible was not ice alone. Ordinary ice shatters under explosive pressure and melts at an inconvenient rate. What Pyke's team arrived at, working with Herman Mark and later refined through experiments at the National Research Council of Canada, was a composite they called Pykrete, after its inventor. The formula was disarmingly simple: roughly 14% wood pulp mixed into water before freezing. The result was extraordinary. Pykrete was approximately as strong as concrete in compression. A standard rifle bullet fired directly into a block of it would penetrate no more than a few centimeters before stopping. Its thermal properties were dramatically superior to plain ice. The wood pulp acted as insulation, slowing the melt rate to a fraction of ordinary ices. In tests conducted on the prototype structure at Patricia Lake in Jasper, Alberta, Canada, a block of Pykrete exposed to a Canadian summer day would lose only a thin outer layer before the melt itself created a protective barrier of wet insulation. The proposed vessel was almost beyond rational comprehension in scale. The plans called for a ship measuring roughly 600 meters in length, nearly twice the length of the largest battleships then afloat, and 90 meters wide. The hull would be 12 meters thick, dense enough to resist torpedo strikes that would have torn through conventional steel. The displacement was estimated at some 2.2 million tons, making it by an enormous margin the heaviest vessel ever built. It would carry up to 150 aircraft, house a crew of several hundred, and be kept cold by internal refrigeration system powered by electric motors. The refrigeration ducts would run through the hull like blood vessels, maintaining the structural integrity of the ice even when sailing through warmer waters. The entire vessel was to be constructed, so far as possible, from seawater. The refrigeration machinery, the motors, the aircraft equipment, these required conventional manufacture, but the hull itself could, in principle, be assembled anywhere cold enough with pumps, seawater, and wood pulp. The estimated cost was roughly £700,000, a figure that seems extraordinary. One considers that a conventional fleet carrier of the period cost upwards of £3 million and took 3 years to complete. Habbakuk, its proponents argued, could be operational in 8 months. The prototype built at Patricia Lake in 1943 measured 18 meters by 9 meters and weighed almost 1,000 tons. It was constructed in winter, kept refrigerated through the following summer by a small electric cooling system installed in its interior, and floated calmly, solidly, stubbornly throughout the season. When workers attempted to demolish it the following autumn, the small refrigeration unit had to be removed first. Without it, demolition still took until the following summer. The lake's natural temperature was insufficient to defeat it. Habbakuk was demonstrated to Allied leaders at the Quebec Conference in August 1943, in a scene that has since passed into the folklore of wartime eccentricity. Lord Mountbatten, then Chief of Combined Operations, reportedly produced 2 blocks in a hotel bathroom, one of ice, one of Pykrete, and discharged a revolver at each. The ice shattered. The Pykrete deflected the bullet. It ricocheted. It narrowly missed an American admiral. The demonstration had its intended effect. Churchill had already been enthusiastic. He had reportedly tested Pykrete personally and written excited minutes about it. Roosevelt was intrigued. The Allied combined chiefs of staff authorized further development. Plans were drawn up for an operational vessel to be constructed in Canada, with production of Pykrete on an industrial scale. Ports were surveyed, crews were theoretically assigned. The operational intention was deployment in the North Atlantic, precisely targeting the Black Pit. The vessel would cruise slowly, it was never designed for speed, with a projected maximum of perhaps 7 knots, serving as a floating aerodrome and refueling station. The sheer impossibility of sinking it, so the thinking went, would make it a strategically useful presence even if it rarely moved. Psychological effects were also anticipated. German naval intelligence receiving reports of an indestructible Allied vessel of implausible scale would presumably find their operational calculations disrupted in ways difficult to plan around. The element of sheer bewilderment had, at least in theory, its own strategic value. American ice carriers were briefly examined and largely dismissed. The United States Navy had conducted parallel investigations into floating ice platforms, but their interest was less sustained and their institutional enthusiasm considerably cooler, appropriately enough. The Americans were simultaneously investing heavily in the Essex-class carrier program, which was producing fleet carriers at a pace that made the strategic arguments for Habbakuk progressively less compelling. The Germans, for their part, appear to have had no equivalent program. Their naval strategy centered on the U-boat fleet and on surface raiders operating from Norwegian fjords. The concept of constructing vessels from frozen water does not appear in surviving German naval records from the period, which perhaps reflects a certain Teutonic pragmatism about material science. What ultimately defeated Habbakuk was not skepticism, but arithmetic.